Geometric sequence.
Hey, instead of adding or subtracting, we're going to now multiply.
Right, we're going to multiply by something called the common ratio. And so this time for our recursive formula, it's simply the previous term times whatever the common ratio gives you the next term.
Right.
So we're going to do what we did on the last problem, except for instead of common difference, we're doing common ratio. So here I'm just going to start up here. For number 1, part A.
Hey, you gave yourself more space on this one, so good job there.
Common ratio. So what are we multiplying by each time to get
to the next term? Yeah.
So
2.
2, and then check along. Yep. We're multiplying.
You can always
by 2.
do stop divided by start to figure that out.
Right.
As well.
So 6 divided by 3 gives us 2. That tells us that's the common ratio. Again, I would like to wait until later to plug in the 10th term. Part C, our first term is 3. And every term after that is given by the previous term times
2.
2, yeah. BD, so D. An explicit rule for the nth term. So now, when I plug in 1, I get 3.
Right.
And whenever I plug in 2,
I want to get 6.
I want to get 6.
Yeah, so basically what you're going to have is your ratio now being raised to some sort of power.
Okay, so like 3 to the n?
Yeah, let's try that and see what
Not
happens.
3,
no,
2.
not 3, 2.
So 2 to the n, because we're multiplying
2 to the n,
time.
and then maybe times 3.
Okay, so let's see if that works.
You got to start somewhere, right? So if this doesn't work, we'll make a change.
Right, so if I plug in a 1 here, I get 2. 2 times 3 is 6. Well, that's our second term.
Oh, so let's just subtract 1 from n, and maybe that will work.
Up here in our exponent?
Yeah, right there.
So now if I plug a 1 in, I do 1 minus 1, which is 0.
And anything to the 0 power is 1.
And 1 times 3 is 3.
That's 3.
If I try 2, 2 minus 1 is 1, and that gives me the 6 that I want for my second term. So that will be the explicit rule. And it should...
Oh, yeah.
That should be something that you can pretty easily do every time, that whatever number you start with times your common ratio to some power. In fact, look, that's right here in our, that's almost like a formula. I wonder if there was one on the previous slide. Whoops. Okay.
There probably was.
There probably was. So let's plug in 10 into this sequence. So 3 times 2 to the 10 minus 1. You're going to have to help me out with 2 to the 9th power.
2 to the 9th power. That's so big. 512.
Times 3? Times it by 3.
1,536.
I'm so glad we didn't do that by hand. Man, that would have been tough.
It would have been really craptastic.
Now let's try number 2.
Oh, God.
Part A. So what are we multiplying by each time? So it might be more helpful to come over here. If I have 10 to the first power, and then my next term is 10 cubed, which is 1,000, what am I multiplying by to get to the next term?
100?
100, right. Or we could write it as 10 squared if we wanted to. But like Hazelwood said, if we divide these terms, it'll give us our common ratio. So R equals 100. We're going to skip B for now. And then C and D. So our recursive rule, we use the first term is 10.
To the negative 3.
Right. And then every term after that
is 10 to the negative 3 times 10 squared or 100.
Right.
Both of those are the same thing.
So that's
the recursive
C.
part. That's C. So D then is explicit. Look at the top of the page.
Okay, so let's try this time. So A is in this case, is our first term, which is 10 to the negative third.
Yep, 10 to the negative third power.
Times R, which is 100, or you could say 10 squared.
Right.
And it's going to be to the n minus 1.
Yeah.
And then we just need to plug in 10 and get our answer.
Yeah, so, oh, geez, that's yet another big number. I'll just start typing it. That's a bunch of zeros.
10 to the 15th.
How did you get that? That's what my calculator said. Look at that. How'd you do that? Did you do that in your head? That's the right answer.
Is it though? Because yours is in scientific notation.
It's 1 times 10 to the 15th.
Oh, you're right. You're totally right. Okay. I just used exponent rules. So 100 to the 9th is the same as 10
Oh,
to the 9th squared, which is 10 to the 18th.
Yeah,
and
aren't
then
you smart?
adding